Hey guys, how you doing here? Good morning, afternoon, lunchtime. It could be Thursday. I guess it could be Friday. So over the next few days here, tomorrow I'm going to be out Friday. So we're going to just chat here for a second. So today we're going to be doing lesson 9, okay, and then I already did the answers for that, um, and then lesson 10, okay. We're going to double out, all right. And if you look, you'll go back here and you'll have to do that for homework. So 9 and 10, okay, over the next 2 days. Also, don't forget about your Khan Academy. It's going to be due, all right. And I'll be honest, I'm not going to be able to check it till next Wednesday or when you get back. But you should be able to get that done. And a new one's going to queue up tomorrow as well on Friday. So you'll have some additional work there. Don't let that get caught up there. And then also for tomorrow in Schoology, while I'm not here, you're going to be working on a digital activity. So you have 9 and 10. You'll have a digital activity, and you'll have Khan Academy. All of that's going to be due next Wednesday. All right. And the reason not why next Wednesday is because we have Monday and Tuesday off. So over these next 2 days, you're going to be pretty busy working. In the back of the room and the front of the room are formulas. You might want to write those down. These two lessons are kind of repetitive. So that's why I've just kind of put these together here for you. Okay. All right. So let's get into this. Number one, I'm not going to worry about this. Use the images below to label the different dimensions with the numbers of cubes in each rectangular prism. Then count the volume of each unit. Okay, so what we're looking at is just counting, the dimensions. There's four, 1, 2, 3, 4, 4, and then we're just one high, right? So when we look at this, it's really the volume is 4 times 1, which is 16 units square. Okay. Next up, all right, is another rectangular prism. Okay, and the idea of this is, all right, is just to take a look at these different things and see how they have the same volume. You wouldn't think that this would have the same volume as this, but let's prove it. We have a 2 length times a width times a height. 2 times 4 is 8. 8 times 2 is 16 units square. So if we were to fill these with water, pop, sand, gravel, they would hold the same amount. And I made a mistake already. This is not square units. This is cubic units. Cubic units. Okay. Okay. So that's where the side length was 1. All right. Now we have to be careful. We have to look at the key. Now the side length is a half. Okay, so when we count, we have to be very careful. So this is these two make 1, these two make 1, because a half and a half is one whole. And we have 1 and 1. So let's write down what we have. We have the length is 2, the width is 2, and the height is just a half, right? It's just a half, because that's what the key tells us. So we have to be careful with this. So now our volume for this is 2 times 2 is 4. Half of 4 is 2 units cubed. Okay. Same thing here. Let's see. These make 1. So 1 times, there's 1 and there's 1. A half, a half, a half, a half makes 2. And then those two together make 1. So the volume for this, when each unit is a half, is 1 times 2 is 2. 2 times 1 is 2 units cubed. Okay. Very good. Very good. Let's move down here. Mrs. Sebastian asked students to estimate how many cubes could be packed into this. How many of these in this? That's what volume is. How many 1 by 1 by 1, or if they change it to a half by half by half, could be filled into that. All right, what process should her students take in order to find a solution? All right, well, we don't have any numbers here. So to me, one of the processes is we could just estimate, right? We could estimate. We could estimate how many of these are in there. So I think we could get 1, 2 across, 2, 4, 6. I think we should get around 6. So visually looking at it, estimating, I'm going to say approximately 6 of those would go in there, right? Right? And then how mathematically could you determine? or if your estimate is correct or not, well, you could calculate the volume of each cube in the prism, and then divide the volume by the rectangular prism. What's that mean? Well, I guess you could just measure this and then see what it is. So it's really still hard to do to check it. So again, we're still estimating this, but I guess we could measure it to get the actual amounts. Okay. So it's hard. It's hard to estimate volume because it's three-dimensional. All right. Okay. Let's flip it over. Let's flip it to the back. Here we go. All right. Let's get to the top. Packing with unit cubes. First, determine the volume of both the smaller prism and the larger prism. Then divide the volume of the larger prism by the volume of the smaller prism. All right, so again, we're packing this with this. There's our side lengths. They're a half. Okay. So when I look at this, all right, this is going to get a little confusing here, so let's talk about this. The formula is still volume equals length times width times height. If we plug in our values, right? Well, our values in this case, if this is our side length is a half, it's a half, and a half. So it's 1/2 times a half times a half. That's our length, our width, and our height. And when I take a half times a half times a half, if you need your calculator, go ahead, you'll end up with 1/8. 1/8 units cubed. That's the volume of that. Now, a little bit different. We have some fractions and some improper fractions, but the formula still stays the same. Length times width times height. Plug in our values. 1/2 times 5 seconds times 3 seconds, right? And then when we multiply all that through, 1 times 5 times 3 is 15. 2 times 2 is 4. 15 eighths. Or we could write that as what? 1 7/8 units cubed. Either one would be acceptable. As you get into algebra, it's okay to leave them as an improper fraction. But these are congruent, they're equivalent, right? All right, excellent. We're moving right on. Let's continue. Determine how many cubes it will take to fill the rectangular prism. Again, same rules apply. Now we're just looking at it. They're giving us some different dimensions. Now, side length is 1/3. So the volume still is length times width times height. If we plug in 1/3 times 1/3 times 1/3, all right, we would get the volume of this little cube, which is 1/27. And it's units cubed. 3 times 3 times 3 is 27. You're getting the idea. And again, it's more of the same. It's just getting into improper. The next one is rational numbers. Let's go. Volume is length times width times height. We have 4/3 times 3/3, which is really just 1. So that's 1 whole unit. And we have 2/3, right? Okay. So 3 times 4 is 12. 12 times 2 is 24. 3 times 3 is 9. 9 times 3 is 27. Okay, now that will reduce. I know it will reduce because this could have been 1. So we could simplify that down and divide both of these by 3 and get 8 divided by 3 and get 9. 9 units cubed. Okay. So again, just some mental math. You shouldn't need your calculator for that, but if you do, that's okay as well. All right. Your homework is on the next page. Okay. I've already done it. I don't want to show it to you too long. But that's part 1. All right. So if you're with me and you're absent, we're going on to the next one because we're doubling out today. Today's a daily double. It's your lucky day. Okay. We're moving on to lesson 10. So if you wanted to pause the video and do the other one, that's fine. Whatever you want to do, it's your choice. They both have to be done by next Wednesday. Okay, so this is just more of the same. They give us some 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 forms or some spreadsheets here to kind of write our information in, and we're just dealing with rational numbers. And remember, a rational number is any number that can be put in fraction form, right? It's rational, right? So decimals are rational, whole numbers, fractions, they're all rational. We got to get it in what we call A over B, and B cannot equal zero, right? And that's the mathematical term of it. Formula: volume is length times width times height. Okay. And plug in your value: 6 times 9 times 4.5. And the volume is going to be what? 243 centimeters cubed. And I'm not going to do all these with you because I'm going to let you work on this. But remember, this formula here, okay, can be rewritten like this: capital BH. This capital B means that they're going to find the area of the base. So I'm going to do one more with this. That means just finding and that's all you're doing. You're finding the area of the base. 6 times 9 is 54. So really 54 times 4.5 is that. Let me explain this a little bit differently. Volume equals capital BH. This formula is the same as this, okay? Why is that? Well, when it's a capital B, they're asking you to find the area of this and then multiply it by the height. So volume equals, and we could write this a little bit different, but it's really the same thing. It's just kind of the commutative property. We could multiply those two to get the area of the base, the area of the rectangular prism's base, and then we can multiply it by the height of 11, right? That is the same as that. It's just written differently. Again, this just means you're going to find the area of the base. And that answer is, what is that? 116 and 6/10 meters cubed. Okay, meters cubed. Okay. So you're kind of getting the idea. These are interchangeable. Just understand when you see this formula, it's the same thing. Okay. If you want to go ahead and take off and keep working, go ahead. I'm going to go for the folks that need just a little bit more work. All right. And let's go back to this one again. Capital BH. The capital B means to find the area of the base, which is 4 1/3 times 12 times the height of 9. Why did I write 12 again? Times the height of 9. That's where I got that number from. So the volume is 468 feet cubed. Okay. So again, I'm just jumping back and forth with these formulas just so you understand it. And they're on the front and the back boards, right? So let's get after this last one here. Volume equals length times width times height. Again, I switch back to this just to show you they're the same. 8 times 8 times 1.5. And when we multiply that through, we end up with 96 inches cubed. Okay. All right. We're doing okay so far. Again, just rational numbers, just numbers in fraction form, decimal, right? These are all rational. We got a couple word problems on the back here. If you want to stay with me, that's great. If not, you can continue to work. All right. So let's take a look at this. A closed dresser is the shape of a rectangular prism. The dresser has a height of 3. That's what I know. 8 1/5. I know that. And a depth of 2. There's a dimension. Are they all in feet? Yes. How many cubic feet? So I need to know the volume. Right? I need to know that. My plan of work is length times width times height. So 3 times 8 1/5 times 2. Okay. And then when we multiply that all out, we end up with 49 2/10 feet cubed. That's important. Circle it up. Okay. Very good. Very good. Let's continue. A shipping crate is advertised to hold 24 cubic feet. Okay, so that's interesting. If a box is in the shape of a prism of 2 by 1.5 by 0.8, how many boxes will the shipping crate hold? Okay, well, this is a little bit different. We better get into this. I know that I have two Okay, 1.5 feet and 8/10 of a foot. I need to know my boxes, right? This is a little bit more involved. My plan is to find the volume, right? To find the volume. So I'm going to go ahead and take length times width times height here. All right, so this is just a little bit more, so stay with me here. 2 times 1.5 times 8/10. So the volume of the shipping container, all right, is 2 and 4/10. And I'll label it at the end, and that's in feet cubed. Now, that wasn't a question, right? I don't think. So the question is if a shipping crate is advertised to hold this many and a box, all right, has a rectangular prism of this and a volume of this, how many of these are in there? So what we're going to do is take 24 and we're going to divide that by 2.4. We're going to see how many of these will fit into that shipping container. Does that make sense? And when I divide that out, all right, 24 divided by 2.4 is simply 10. So it's 10 boxes, right? 10 boxes, 10. So I found the volume, all right, by multiplying these numbers. This is the volume of one box. Let's go over this, all right, of one box. How many of these will fit into 24 cubic units? I took that and divided it out. Okay, so getting a little bit more involved there. Let's take a look at the last one here. So the last one's up. A music stereo is packed in a box shaped like a rectangular prism that measures 18 and 5/10, 32 inches by 12.2 inches. What is the volume of the box? Okay, so this is what I know. I know it's 18.5, 32, and 12 and 2/10. Now we got to make sure that they're all in the same units because they're going to start switching these around, I bet sometime. They're going to put one in feet, one in inches. They could even put one in centimeters. We have to do some converting there. My plan is volume is length times width times height. So it's 18.5 times 32 inches times 12 and 2/10 inches. Okay. So when I get that, I'm going to get my volume as being what? 7,222 and 4/10 inches cubed. Okay. So again, this was another lesson on volume, just like the first one. You're going to be doing this for homework. So you have 2 pages of homework. Let's go over this one more time. 2 pages of homework. You have Khan Academy due this Friday, and you'll have Khan Academy due next Friday. You have a digital activity due next Wednesday as well. So Khan, homework 9 and 10, and digitals due next Wednesday. There's a new Khan set up for next Friday as well. I wish you the best. Good luck, and have a good Friday too, because I'm not going to be here. Bye bye.